Good morning. Welcome to the second webinar in our Kicking Asset Management series. This is brought to you by MentorAPM. MentorAPM helps utilities transform their operations through our leading edge asset management and APM software solutions. In this series, we are covering fundamentals of building successful asset management and asset performance management programs. The webinars are delivered by our co-founders, Tacoma, Zach, and John Clow. Today, Tacoma will walk us through criticality and risk fundamentals. We're going to take a quick look at the principles of criticality and risk. We're going to show you some of the process for conducting a criticality analysis. And then we're going to cover a couple of case studies that are going to show you the potential outcomes of applying criticality and risk knowledge to an asset performance management framework. Please be sure to submit your questions for Q&A at the end. Just look in the menu bar for the Q&A button. Today is going to be a very high-level overview of a lot of important information. So we want to point you to some additional resources. Tacoma has written a book called Criticality Analysis Made Simple, and that's available on Amazon. We also have a video on our YouTube channel on 8 common mistakes you don't have to make in identifying critical assets. And we're announcing today that we're making available a low-cost, limited criticality pilot engagement that will allow you to experience all of this for yourself in your own utility, working with your assets, and preview the potential results you can achieve. So today we're going to move ahead and talk about criticality analysis. Turn it over to Tacoma.
Great, thank you, Jennifer. Thanks again, everyone, for joining us this morning or afternoon. I guess depends on what time zone you're in. And it is a pleasure for us to be able to do this. We really like this particular topic. We love asset management. We love criticality analysis. It's something we've been engaged in for about the last 15 years. And have we think have an approach that is extremely efficient, that casts the net very wide and allows you to be very inclusive of all your assets. But also, how does this end up fitting in with an overall or an existing asset management program or one that you're wanting to develop? So we're going to move forward and through the asset management playbook that we started last week, or I should say our last, not last week, our last webinar. And in that one, we spent a little bit more time on the mission and values, the idea of alignment and the idea of that essential element of an asset management program. And so what we're going to talk about today is looking at how criticality analysis really helps us focus and helps us shape towards maintaining that level of service that we discussed last time, and making sure that we're making risk-based decisions about our assets, and so that we have an asset sustainability as well as a fiscal sustainability over the long haul. Because we really wanted to make risk-based decisions. We're wanting to make decisions that extract the maximum value from our assets so we don't replace them too soon, and also so that we don't keep them too long as well. So what we're going to be talking about today is really a sharpening and a focusing exercise. So we do have a lot of stuff to cover, but we're going to try and leave a lot more time for questions and answers. So let's talk a little bit about the principles first. Well, as an additional resource, like I said, and Jen had mentioned, we are talking about some top line stuff here. So we do want to point you to some additional resources that we have, some videos that we think are not only entertaining, but also informative. And then there's just a little bit of things to note about criticality, risk management, just a couple things to keep in mind to make sure that we stay within the bounds and that we actually get the results that we're looking for, and that things don't go off the rails. So one of the things is that risk and criticality are often confused, and there is a lot of literature out there, and there's a lot of things that are written that well-meaning folks have put out there, but it tends to confuse. It also tends to obfuscate, which is another word which tends to hide what's really going on. And they are related, but they're not the same. And we're going to cover this a couple of times today, but criticality really is the measure of the relative importance, or how important something is, an asset, to the mission, the values of an organization, the objectives why that facility actually exists. And assets are not just the physical assets, but assets are also things like data. And so we want to keep that in mind as we do this, as we go through a criticality analysis. And risk is really the function of that criticality, or how important that asset is, what type of impact it has on our overall mission and objectives when it fails, and marrying that or merging that with the likelihood of that failure. So when we take likelihood into account, that's when we get risk. Otherwise, we're dealing with criticality. A couple other real quick things. Cost and condition are not reliable indicators of how critical something is or the potential risk. And we'll do some examples, or show you some examples about that today as well. But just as a real quick example, is when it comes to cost. You can go and pull a $5 spark plug out of your car and see how far you get. The expense of an item, the expense of an asset is not a reliable indicator of how critical something is. And so the other thing is of course, and this is the reason why we have criticality at the bottom of the pyramid as a foundation, is that it is so important in understanding where we need to apply our resources in order to make sure that we secure and maintain that level of service and the reasons why that facility exists in the first place. So I think large context, I think we're probably talking to a lot of municipal utility folks on the webinar today. You may be at an industrial facility, and we have some information for you guys as well. But what we're going to talk about is really applicable to anything, whether it's power utilities, water utilities, wastewater, refining, you name it, any kind of industrial or municipal asset-intensive facility is really where there's tremendous impact. All right, so a little bit about risk. We're actually pretty good at risk perception. Through the eons of our development, we have learned to be able to recognize risk, so that when we're in the wild and we're faced with a tiger, we tend to run. Once our brains, particularly males, fully developed past 25 years of age, our risk perception seems to be a lot better. We've also developed a lot of tools about risk analysis, and there are some fabulous tools out there, from Famicas and Weibull analysis and Monte Carlo simulations, and we can do a lot when it comes to having the tools developed for risk analysis. But a lot of times we tend to fall down on how we manage that risk, and we're going to deal with a little bit more about that today, and how do we take the stuff that we have pulled together, how do we actually go ahead and manage that risk? And this is an area perhaps where we could use a little bit of help. So, clarifying a couple of terms. A lot of these terms we dealt with last time, so I won't go into them very much, but just as a little bit of background, and if you're interested, you can view our webinar. It's been recorded, and we'll happily send you a link for it so that you can watch that. But the two that I really want to talk about again today are criticality and risk. And criticality, again, a little bit more simple definition here, is that it's the potential impact of an asset on the level of service. You can distill it down to this. So the potential impact of an asset, if it fails, on the level of service. And it doesn't even have to be really an asset. In fact, you'll see later today, as we do this webinar, that it could be systems. And in fact, there's a reason why we like to take a look at systems over assets. And risk, again, is that relationship between the likelihood of an asset failure or a system failure and its criticality. And there is a simple formula that's posted, and it's within the ISO community as well, and it's in most of the considered literature. And that's a very simple formula to recall, and you can use that. All right, and we're going to talk a little bit very briefly about failure modes as well, but actually at a system level. But those are very, very important as well, because those impact how assets fail and their likelihoods. So, big question. And to dispel the confusion, we need to understand what is critical and what isn't. And so I have a question that we love this one. Is this pipe critical? And if we watch movies, and particularly, the infamous Scotty on Star Trek, the reactor's going critical, is actually a misnomer. This pipe is in derelict condition. Its condition is poor, and that is evident from what we see. What we have no clue on is whether this asset is actually critical or not. And there is a tremendous degree of misidentification in a lot of the literature, publications, work that's done out there, where people are looking at their assets and go like, and they look at something like this and go like, yeah, you know what, it's critical, it's in critical condition, we got to get it out, and we got to do something with it. Well, maybe you do, and maybe you don't, because like I said, I don't know anything about where this asset is. I don't know what it really it does or how important it is to my overall objectives. Contrasting this picture of this derelict asset with this schematic. Here we have a typical water distribution system that is going all over the place. And if you follow the pipes around this night, you'll notice that we have a hospital in the lower right-hand corner, and there's really only one pipe going to that hospital. And there's really only one route for that hospital to acquire its water. And it's that last dogleg. And when we look at this particular schematic, we realize that for the hospital to deliver on what its functions are, its main objectives, it's going to need water. And that pipe, that last dogleg, is absolutely critical to that hospital being able to maintain its objectives and the reason why it exists. And so that section of pipe is critical because of what it does. And criticality is related to the function of that asset or system in delivering for the overall service. It does not involve condition. Criticality is not a measure of condition. And it's a really, really important distinction. So if you don't like the word criticality, maybe the word essential is a good word to consider as well. All right, well, let's take a look at the process a little bit. How do we end up actually performing a criticality analysis that is relatively simple and yet extremely effective and very much delivers on the needed type of information and the needed results so that we can make accurate decisions about risk, where we need to apply our resources. And there are really hard ways of doing it. They're good, but they're hard. And then there is an approach that we're going to talk about, which is much more simplified without cutting corners and without giving up anything about value and usefulness. And so first place we have to start, and we talked about this a lot last week, or last time I should say, is the who and the why. Why does the facility exist? And this is just a brief reminder about the alignment that is required. We must take the objectives of why the facility exists from senior management, identify the values that the organization holds to. How much do we care about safety? How much do we care about environment? How much do we care about regulatory issues? Those kinds of things. We'll talk about that a little bit in a second more. And then we need to look at the asset portfolio itself and come up with an overall delivery that we are supposed to provide to our either ratepayers, customers, or the public. And that look as our overall level of service. And these are then broken down into more detailed or granular view, which is looking at the systems. Facility is made up of a whole host of systems. You can think about it like in your filing system in your computer, you've got folders inside of folders and that sort of thing, and they all sort of end up going to the C drive. So it's that kind of thing where we look at our overall facility, we break it up into various systems that then are made up of assets. And I'll show you a graphic about that in a couple of minutes. But this is where we do the analysis, because we find that this is the most effective, efficient way of doing the analysis. We do this at the system level. So there are principles borrowed from RCM, there's principles borrowed from what the Navy does, from a historical perspective, how to gain this information in an efficient manner. And you'll see some really cool stuff in a couple minutes about why this approach really, really works well and why it's preferential. And then, of course, what we're trying to do is making sure that we identify critical system performance and critical systems in order to meet the objectives so that we can then appropriately apply the correct asset strategies on how we will manage our assets. And you'll see a little more detail there. So this is sort of the starting point for getting alignment, making sure that what we do is aligned with corporate objectives and the values, and that what we measure in the field and what we measure tactically is actually going to deliver on what we end up doing to support the main objectives. But who gets involved in this as well is really, really important. And so we showed you this graphic last week as well. So, you know, when an analysis like this is done, so often we've seen it done just by engineering or by maintenance, or, you know, it's those two, and they kind of work in their silos and they tell you what's important. And there's not a whole lot of cross-pollination and a lot of crosstalk. And so what we found is that, and the qualitative approach that this method really benefits from employing a representative from every one of those functional groups, and at minimum engineering, operations, and maintenance, but also some input from finance, IT, and even purchasing. So you want to keep the group size manageable, so maybe no more than about 6 people. But they must be represented by a cross-functional group, because everybody has a stake in this. Maintenance is trying to look after equipment that operation needs, because operations is trying to deliver, but if they don't let maintenance look after stuff, the operations isn't going to be able to do their job. And engineering sometimes has to engineer out risk and can offer some good insights on how to have better maintainability. And IT, actually, when we're looking at electrical infrastructure, we're looking at IT and the increasing prevalence of IoT, that's also beginning to take on a larger role, especially when automation comes in, and we want to be able to have a robust system that can withstand some stresses. All right, so what do we end up delivering out of this? And this is a typical matrix that represents the alignment and the scaling. So on the left-hand side, you'll see values an organization holds, and this is actually one out of an actual client. And there were basically 5 main values that this client held to, and probability is also dealt with. I just didn't show it on this particular screen. And then there's definitions associated with each one of the scales. So when something really bad happens for safety, it's defined. It's very clearly defined what is not acceptable, what is deemed a never to happen, as emblematic of the red colors. And that's scaled all the way down to something like blue, and which means, you know, there's virtually nothing going, or the impact is minor or negligible, and everything in between. We've seen some out there that are good. One thing is that we really encourage is that these scales also include the notion of the rate of impact, the ability to mitigate, and also the level of severity. So those need to be in there. Without that kind of verbiage in there, it gets a little bit, it's an incomplete analysis. So what we do then is we capture this, and we'll show you why we actually use a tool. We capture these definitions, actually, you'll see them on the right-hand side next to the colors. And all those categories are on the left-hand side, and they're also weighted. Because every organization will have things that they care about a little bit more. And does a company put profits over safety, or safety over profits? Do they care more about PR, or do they care more about regulatory? And do they care about the environment? And regulatory and environment often are different. They're related, but they are different. And so one other thing that we find very valuable, and this is another reason why we think a tool is really useful, is because when you're dealing with hundreds of systems and thousands of assets and all this information that we're going to show that you can capture in an efficient way, a database is really the best way to go. And so what we do is we also give an opportunity to mess around with the numbers a little bit. So under the red box here, you see there is something called the category scaling factor. And what that does is it changes the relationship of the scale from red to blue. So how many blues does it take to beat a green, kind of thing. The other thing that we do is we allow the opportunity to adjust the impact of probability, or the frequency of occurrence, and it depends on how the analysis is done. And this is a unique element as well, because what we're really trying to do is that once an analysis is done, provide an acid test, not an asset, but an acid test. We really want to make it difficult for systems to distill to the top, so that we can really identify the bad actors, the systems that truly pose a risk to us. And we found a very efficient way to do that is to be able to monkey around a little bit with these numbers and see the net effect. All right, so one of the principles that we've got, and this is why we look at the system approach, is that we say include everything in the analysis. If you leave assets out, if you leave systems out, you will have undiscovered risk. And so this is an actual example, again, of one of the facilities that we worked with. And what was on the books in the asset register were those yellow pumps. And there are actually 4 green pumps. They're a little bit off to the right side, and you can't really see it because of the ladder that's going over the berm. And so really, they only had 7 assets in the register related to this particular function in this facility. And this happens to be an extremely dangerous room for health and safety reasons, so much so that there are actually 2 emergency showers in this room. And one is right in the middle. The other one is far off to the right off screen. You can't see it, but you can see the pipe, yellow pipe going to it. And in fact, because this is a chlorine mixing room. And so none of those pipes, none of those little orange and black valves, none of the graduated cylinders or the pressure meters, nothing was included. And yet every one of those assets, every one of those components poses a performance and safety risk. And so the approach we've developed really encompasses and allows you to capture these during the analysis. And so we say, yes, you need to include everything. If you can physically touch it, you should be including it in the analysis. And we've gone further to that and say, you know, if you can touch it with if it's data, if it exists, then yes, it should be included at some point in an analysis. So the question some people also say is, how do I have to count everything? Good night. I mean, if I did that, if I looked at that previous picture, there's so many valves, so many pipes and all that sort of stuff. How do I have to count everything? And that can seem an extremely daunting task, especially if you're using some of the really cool tools that exist, like Famicas or some other tools that get very granular. And we're looking at failure modes of actual assets. It can get very granular because you've got components and subcomponents. And so not to get bogged down in the sea where you're trying to count every potato, we have a different approach. And that approach really is to say, let's take a look at the systems. Because now we can go from thousands to a few hundred, if that. And usually we find that we never really exceed about 180 on even a huge facility, about 180 systems. And the smaller the facility, yeah, the numbers come down. So this is an example of a typical pumping system. It's actually taken from another facility that we did an analysis at, and you'll see there's everything in green is part of this pumping system, and it's actually a return activated sludge system. So there's a tank at the bottom, which is you can see sort of the blocks in the bottom. There are the 3 pumps in there. We include motors, the controllers, the piping, the valving. It's all there, and the system really starts where the tank is and ends when we get to the next process. What you'll also see is that there is this blue stuff, and the blue stuff actually is a seal water system. Well, this is really cool. When we're doing this analysis, we were talking about, well, if one of the pumps fails, or what the history has been and what the frequency of failure has been and all that. And what was really cool is when we asked the question, well, what happens when the seal water system goes down? Oh, well, then the whole thing goes down. And all of a sudden, there was a re-ranking in priorities of the seal water system, which had actually been ignored a little bit. So there's some advantages to taking a look at this that helps you see the big picture. So what we do is we essentially take a look at a typical P&ID in a facility as a whole, and we break it up into appropriate systems based on failure modes and the number of assets. And there's some nuance there. And if you want more detail on this, please, feel free to read the book. There's more guidance in there, or you can call us up afterwards. And then what we do is we relatively rank all the systems against one another in terms of their impact on the values of the organization, so health and safety and regulatory and all that, and the overall level of service and the mission of the organization. And this is much easier to do at a system level because you're much closer to the overall facility size. And so then what we do is we say, okay, let's take a look at this for a second. And if I take a look at this green system here on the side, maybe I should have picked blue, but look at the green one. And a green system has relatively minor impact, such that when that system fails to do what it's supposed to do, the impact overall, the things that we care about, is relatively minor. Contrast that with when we look at this red system, which is, bad stuff happens when this system fails, whether it's safety or a level of service. And what we know is that this is a critical system. The green one wasn't. Now, if we know that this is a critical system, this is the big takeaway. And that is, only critical systems have critical assets. So now by looking at the system perspective, you've been able to winnow down where the critical assets reside very, very quickly. This is a massive time saver. So how does this analysis actually progress? How do we actually get to this part? So we're working with our cross-functional teams. What we do is we identify the systems we're going to take a look at. We go through them one at a time. And then what we do is we say, okay, look, systems kind of have failure modes as well, and we call them failure scenarios. But they're kind of similar to what a failure mode is, only it's at a system level. And we have a preset defined set of those. And we take a look at the exact nature of what happened in the past, and we can look at as many scenarios as we really want, but there is some good guidance as to how to limit this to keep this manageable. We've done this so many times over the last 15 years, we know that there's actually not much value in doing more than about 5. There are ways in which you can eliminate, and the results actually are unaffected by too many analyses, so it's wasted work. So let's say 3 is a good number. We took a look at the exact way in which a system actually failed, and then we grade it with the little rainbow colors there in the sliders on the degree of impact that failure and on those conditions actually had. And we talk about it in the room a little bit more about other ones, and the ones that are really important are the ones that distill to the top, because we're trying to find out the maximum impact this system can have on our level of service and the values that we hold to as an organization. So, so you can see that we now are beginning to look at scenarios that have different consequences and different probabilities. Well, we are able to composite those together into a system view of the risk and criticality that system poses in a composited view. And this is also a space where we can actually, if we want to, allocate these numbers to the asset level. And you'll notice that right now, just on the top there, it says system, and we can actually do the asset level as well, or we can allocate the results to the asset level and then maybe do FAMICAs when we have those important systems. Then what we do is we provide a overall risk ranking, and there's 2 things here. One is a relative rank of all the systems and thereby all the assets as well, either by impact, which is criticality, or probability or frequency of occurrence, and risk. And so now we have a great relative ranking of these things, and there are reasons why a group of people are able to do this well and statistically insignificantly different from a numerical approach. But we won't get into that, but if you want information on that, you can look at our book. But it also provides a graphical view of the facility as a whole. And this is really useful when the analysis is repeated every couple of years, so you can see not only where your risk systems are, but how large or how many systems there are based on bubble sizes, but also the shift as the years go by, hopefully into the good quadrant, which is the lower left quadrant, and away from the red areas, which are in the upper right. So again, what are some of the other benefits that we have from an approach like this? One is, because we're dealing with a cross-functional team and a cross-functional approach, we end up having a greater degree of collaboration. Engineering understands why operations or maintenance is something, and vice versa. There's an agreement on priorities and a tremendous degree of alignment. And to be honest, at the end of the day, it just ends up being a big love fest between all the different groups. Perhaps that's a little bit of an exaggeration, but we have seen a marked improvement in collaboration and using criticality as a means of speaking the same language between the different functional groups. And that includes even the purchasing people, who now begin to understand maybe why selecting the lowest bid isn't always the best approach. Okay, some of the outcomes, and we want to move on with this to make sure that we leave some time for questions as well, that we aren't just talking about theoretical things, but this is actually translated into tangible financial and risk-related results. So what we're going to do on the first example is we're going to move from our criticality analysis to some PM optimizations and PM review, as well as then what kind of operational changes were made. And so we're going to go from criticality to PMs to operational management optimizations. So here's a result from an actual facility that we did a couple of years ago, a very large regional municipal operation. And After the analysis, we said, okay, great, here's all this, here's your systems in terms of risk rank and criticality and also frequency of failures in the past and what we want to do in the future, that sort of thing. What do we do? Well, if we stop here, we end up really having a great list, and maybe can look at where the risk areas are and say, well, here's some capital projects to address these risks. But what we did was we took a look at the risk ranking and compared it to the previous analysis. So here's a comparison between the revised risk ranking, which is in green, the Mentor green colors, and the before numbers. And the before analysis was pretty well a couple of people sitting in a room throwing darts at the wall, telling others how important their equipment was. And they were using a scale of 1 to 9. They were using Oracle. And the great thing is, again, what we're talking about here, these booster packs with the criticality analysis or the asset performance management stuff, is that we can attach to existing CMMSs, so we don't obliterate somebody's existing investment. We actually boost it or we enhance it so that you can do some of these things. Anyways, so there's a scale of, in this particular case, from 3 to 9, nobody felt their equipment was worth a 1. And so we look at this and go, oh, okay, well, it's not too different. Maybe there's a bit of a blip in 5. Maybe more equipment is actually a 5 than we thought before. And there's a few more 8s. But that is not where the real story was. The real story was in the switch, was in the idea that, wait a second, did we accurately estimate or assess the criticality and the risk of our assets? There was a tremendous degree of movement. 71% of the assets now scaled at 8 or 9 came from a 3 or 4 previous ranking. And 44 came from 6 to 9 down at the bottom. What this is saying is that 71% of the assets that are actually posing a significant risk or that are actually critical previously were deemed insignificant. Similarly so, 44% were deemed very, very significant and actually are not. And then there was a bunch of shuffling that took place in the middle as well. This led to some subsequent analysis, which is also really telling. And I'm just going to show you the highlights here. One of which was when we looked at the risk of the revised rankings, we found out that there was a lot of risk being borne by this utility, driven by the frequency and the likelihoods of failure. The assets were relatively critical or very critical, and the failure rates were very high. And there was a lot of risk all of a sudden being borne by this utility. When we took a look and say, what about the preventative versus the corrective cost? And we did things by hours and a number of work orders and all that stuff, but we distilled it down to cost. And we looked at preventative PMs as well as the corrective by costs, by risk, and we ranked them by risk. We realized that whatever we were doing in the blue on PMs was not, because there was a lot of cost that was being associated with corrective work orders. Way too many, especially in the categories of risk and criticality from 7 to 9. And the other part too, which was rather telling us, is that there was a relatively way too much focus on assets that were deemed a 4, way more PMs performed on them than necessary. And so, there's a funny formula, and every place is unique, that you have to sort of come out with, for every PM dollar I spend, what's my reduction in my corrective work order? And on a subsequent webinar, we'll talk about asset strategies and management strategies related to failure modes and that kind of stuff, some RCM kind of related things. But to suffice it for now, this was one of the major outcomes where we looked at and said, you know what, we've got to change what's going on here. So there was a need to rethink the preventative maintenance, corrective maintenance analysis, looking at, say, where are we spending the effort right now? Have we been doing the right thing with our PMs? Are we introducing infant mortality? Are we actually doing the right PM to adjust failure modes? That kind of stuff. And then also drilling into the outliers. And what are the costs? Are we outsourcing any of this work? Is the equipment too difficult to access? That kind of stuff. They all sort of go into the analysis. So this wasn't done sort of just willy-nilly. But here's the key takeaway. In their maintenance budget, $5 million was reallocated to shifting priorities to where it mattered, aligning them with criticality and risk. So aligning resources to criticality and risk, and another $5 million was estimated in a reduction that was possible for their maintenance budget. And that is a significant savings to the bottom line. This is not just an academic exercise. There's real dollars to be saved here. All right, let's move on to the next one. We move from criticality to condition assessment to capital planning. So we're going to move up like this. And this is an example that we did a few years ago as well. This is an industrial facility, provides processed water, RO water, to a facility. And these are the ion exchange columns. And they were slated for about $1 million or so of refurbishment, a capital project that we thought was the most important thing. But prior to engaging in this thing, we decided let's do a criticality analysis. And then during the analysis, we looked at all the assets again. And what we found is that part of this system was a little pump station that had really gone unrecognized and sort of tantamount to ignored, and nobody really understood, how important it was. And when we did the analysis, we realized, okay, this was the pump station that was at risk, and or I should say that was at issue. And we decided to take a look at the history of maintenance and what went wrong. And this is an example of the kind of stuff you can do. You can look at the condition history as you found it, the condition history as you repaired it, the stress scores, looking at like the failure modes at the bottom and saying, okay, what were the components that failed and what was the correction, and doing a bit of an analysis at this point and tracking the performance of this thing over time. And what we realized during the analysis was when we looked at the frequencies of failures and the potential impact was that little pump station was the most critical and posed the greatest risk to the entire operation. And the numbers were pretty significant because we looked at a $1 million capital project, which we were able to defer for a few years. And instead, that year only did a $12,000 pump replacement capital project instead. And so we figured, okay, you know what, we've saved a lot of money. This is really, really good. We're great about that. But what's really telling though too is the commercial risk versus the asset cost risk, or the asset risk cost. And when we looked at that, this was the multiplier. That for every dollar we were spending doing the pump replacement on the critical assets, we were saving over 250 times that amount on commercial risk. So a $12,000, let's say $10,000 pump system is a $25 million commercial risk. There's a massive amount of leverage taking an approach like this when you take a look at the numbers. All right, last one, a little bit more of a setup for next time, but just to show that where this also goes. If we take a look at a criticality analysis again, and we say, okay, what about condition monitoring and our operational strategies and capital planning? This is a very familiar curve to many people. It's a failure mode curve. And so our criticality analysis driven asset performance takes a look and actually prioritizes and relatively ranks our asset portfolio in terms of how critical they are to our mission. And if we take condition into account and look at likelihoods of failure and all that sort of stuff, there's a lot of stuff you can do. Then you're looking at your risk as well. Initially, we just take a look at frequencies of failure. It's very easy to understand. It's very easy information to gather. But then what you do is you say, okay, look, for those critical assets, you look at, on the left side, we want to do some precision maintenance. We want to do some ongoing condition monitoring. As we see here in the curve, the ongoing condition monitoring in the middle of the second green part, that first arrow on the bottom there is pointing to condition monitoring. That's what we want to do on the left-hand side. And as our assets are scaled relatively all the way down to the relatively insignificant ones, those are the ones that we can just do corrective on and maybe even let them run to failure. What we're trying, and everything then in between. So we need to understand how assets fail. We need to relatively rank them, and we need to come up with appropriate assets, managing our asset strategies so that we can do the right thing to the assets for the right reason and maintain that level of service and apply the limited resources we have in the right area. And so this isn't, we're not advocating IoT for everything. We're saying, let's be really judicious. Let's be really smart about this. And so again, we take a look at how our assets fail. We look at our condition before, we look at our condition on refurbishment, we track this, our condition profile as time goes by, our performance profile as time goes by. We look at the actual failure modes within that apply to our assets. And a CMMS needs to be able to support this kind of information capture. And in fact, not only does MentorAPM, the app does it, but our mobile application lets us gather that information out in the field virtually seamlessly. And with pull-down menus that are all filtered appropriate to the right assets so that this information is done and captured correctly, it's normalized, and we don't end up having kind of wonky things that we've got the wrong kind of failure modes for the wrong kind of asset. It's all done so that the information we have is actually useful and usable and allows us to make those kinds of strategic decisions. And so with that, I'm going to hand it back over to Jennifer and announce some of our upcoming engagements.
Thank you, Tacoma. We'll open the floor for questions momentarily. Please take advantage of the Q&A option at the in your menu bar. You can type in a question that way. I'll also give you the chance to raise your hand and best to try and catch that and invite you to ask the question directly. So as Tacoma was wrapping up there, previewing some of the capability of the MentorAPM Work and Asset Performance Management Suite, just want to let you know that is a complete CMMS EAM solution that does have integrated mobile and GIS. But we know that not every facility is in the position to engage with a totally new CMMS or EAM. And so we've packaged up the capabilities of the suite into booster packs that you can then take to enhance and bring all this functionality into your current system. The booster packs are system agnostic. We have open APIs and they can integrate with any existing system that you're using. What we talked about today is the Criticality Analyzer module, and it is part of the Asset Performance Management Booster. We also have a mobile work management booster, and coming soon in this year, we've got a pretty amazing work order load leveling module that is in development right now. So one of the other things that we're making available to you, I mentioned earlier at the beginning, as a Criticality Analyzer pilot. We'll go to the next slide. So yes, we have packaged up a limited scope 30-day criticality analysis pilot that will come under signing authority. You wouldn't have to go to a full RFP for this, but this allows you to trial this process and preview the software, take an actual walk through a criticality analysis, preview the benefits, and evaluate the potential outcomes for your facility with real results, not dummy data, but your data, your facility, your potential outcomes, and see, can you also look at saving $5 million? Can you also look at reallocating $5 million? Start to get an idea of what is your facility risk profile. In these times, we do have remote facilitation available, and we also hope to be able to travel to you in the near future. So if you'd like more information about this pilot, please contact me and we can get you pricing and information. So we'll move now into questions and answers. I have our first question. So we have a question relating to the outcomes in the industrial facility. How was that 250-to-1 ratio pump replacement calculated?
Actually, quite simply, we looked at what the commercial value of the contract was. We stood that we looked at also at our consequential damages. So part of the analysis and part of the original alignment component was looking a little bit beyond the typical and included consequential damages, other commercial terms, other legal implications, triggers for performance, all that. And so they were sort of part and parcel with the performance part, and we also had separate categories for, like I said, for consequential damages and all that. And so when we looked at it and said, okay, well, what's the value of the contract over the term and the opportunity to be dismissed from the site, and how fast could this pump system shut us down without an opportunity to mitigate? I mentioned at the beginning that the rate of impact is important. The opportunities to mitigate come into the analysis and will help determine where they fall on the scale and how quickly those consequences can accumulate. And when we looked at that and we realized that we had an extremely short window, less than one shift of failure, it was acceptable to the management to assume that when we looked at the cost of that pump and the cost of the contract, that was the ratio that was used. Because the consequences were going to be an immediate dismissal from the site.
All right, we also have a question from Luis. Do you also look at power outages?
Yeah, they can be actually. You know, it depends on at levels of service. If they are internally, when we do internal reviews for utilities that have their own electrical distribution systems, and then we do electrical systems, we usually follow on after the mechanical, because in that particular case, the mechanicals are the primary reason the facility exists. The electricals. However, if you're looking at an electrical utility, its primary objective is to deliver. And so then you need to begin to take a look at commercial terms or service obligations to the distribution network and what kind of penalties there are. So the outages, whether they are part of a overarching level of service or if they are buried deeper inside where there are opportunities to mitigate, these all need to be context sensitive depending on what the analysis is, the scope of the analysis, what kind of utility it is. So the short answer is absolutely. The long answer is it depends if you look what you're actually looking at, how that makes its way into the analysis. But with a question, it should be included.
So
in fact, a little bit more on that note, actually just a little bit more on the note, because those of you who know me know I love to talk. Give me a microphone and I'll be there forever. So the other part when you're looking at outages is, let's say in an industrial facility, outages often are required on an annual basis and can fail until you hit that outage. Sometimes they're referred to as turnarounds. And so everything needs to stay running until a defined period of time when everything is maintained and everything is brought back into tip-top shape. That really drives some other asset management strategies, because in that particular case, things that are critical are not allowed to fail. So that will drive some of the additional tactics that would employ to keep those critical assets running. So that when everything fails, it all fails just before the turnaround or just at that period of time. Sorry, I wanted to add that point in.
Sure, and the next question from Andrew actually is a great follow on that, you know, the idea of worst scenarios, so power outage being something that you may or may not have control over. So Andrew asks, I have heard of evaluating criticality based on a worst credible scenario. How could the results be compared to reviewing multiple system level failure modes?
Great question. So the objective absolutely is right to say, look, we're looking for the worst case scenarios because we really want to identify what impact systems can, and I'm talking about at the system level now, and even where it applies to the assets as well. But if we're looking at the system level, we say, okay, what is the absolute worst that this system can do that's credible? And you know, we have a saying in our own company that when we look at these things, you know, we exclude asteroids, earthquakes, and outer space aliens, unless you're in California, and that's when you do include earthquakes and you do include outer space aliens. So, but when we're looking at our systems in general, we need to understand how significant the impacts are. We can do analysis till, you know, the cows come home on all the 5,000 things that can slightly go wrong with an analysis, but there's no real merit in that. There's no real value. Some of those things will eat your lunch in terms of some time if you're going to spend effort there, but that doesn't tell you how important the asset is. What you need to understand is what the maximum impact is. And that's why, you know, when we've done these analysis so many times over the years, we know that at the most we've ever come up with really is maybe 5 or 6 different scenarios, and it's really an unusual circumstance. For the most part, the most significant impacts on overall facility objectives and the values of an organization are usually within about 3, maybe 4. scenarios. They average about 3. There's a bunch that are 2. There's a whole pile at 1, there's insignificant ones, because they don't really impact your organization that much. So while you can go and take a look at 100 or tens of scenarios, the merit isn't there. And that's one of the things that we do when we facilitate the approach. We actually train you to do these analysis on your own eventually. So we, on the initial facilitation, as part of it is training, but we guide you along the way to show you that and help you think about it in terms of looking for the worst case scenarios. We're really trying to understand, when we lose pumping, or when we have blockage, or when we lose power, what are the maximum effects that have happened in the past. That answers your question.
So we have another question relating to the bigger picture of asset management, which Criticality and asset performance management is a part of. And if you haven't seen our first webinar, you can download that, view that, where we cover the idea of an overarching asset management framework. This is a very good question. Do you have samples of plans that you have already created for existing clients, or would you be able to preview what an asset management plan would look like? Asking because there are so many companies out there selling asset management. So how is our asset management different? What do our asset management plans look like, Tacoma? First question I've got is how rigorous or comporting to, say, international standards do you want to be? Almost doesn't, maybe I shouldn't have said that, because it almost doesn't matter what the answer is that generally speaking, yeah, we actually have some things that are pretty well thought out already. We have a definite map that is fairly concise. There is a lot of stuff that you can do for an asset management program. But the principles and the benefits really can be derived by doing a few things well and a few things smartly. If you want to comport to ISO 55000, which, by the way, MentorAPM and our approach fully can support through very detailed tactical execution, the idea is that then you're going to need certain documents, but if you don't want to do those, if you're looking at low-hanging fruit, there are some pretty simple things that you can do. To be quite honest, the pyramid we showed you before. Let me just back up a couple slides here. I don't even know if I can here. Hold on a second. Let me find out here. Oops. Let me go back up here. It's not letting me go back up. I don't understand why. Oh well. And now I'm stuck here. So maybe. Let's see here. There we go. This asset management pyramid really was driven in order to show how the tactical elements all fit into place in order to deliver what an asset management program is really supposed to do. There is a lot of detailed work you can do at almost any one of those levels within this pyramid. We would say, if you at least take a kick at the can with doing a criticality analysis at a functional level, you don't even have to include your assets just yet. And figure out which systems are most important, and then focus on the assets inside those. And then come up with some strategies for PM optimizations and conditions, stuff like this. Again, you can do super detailed in any one of these levels. The question is are you going to drive the benefit you're really looking for? So we sort of advocate saying, hey, listen, let's take a look at the pyramid overall. Let's take a look at this roadmap. Let's figure out where you're weak, where you're strong, and leverage some of your strengths. And then just sort of fill in the holes along the way and say, okay, first cut, let's get to the top. All right, now you want to be a little more detailed on any one of these levels, take a second run through it, and then a third run through it, a little more detail, a little more expertise, a little more competence, and you bite off as much as you can chew. And so we know asset management can seem daunting, and asset management has had a lot of people talk about it, and it can just seem like, oh, I need the world's greatest experts in it. There's a lot of asset management we do in our private lives. We don't even realize it. If you want to get the most out of your vehicle, there are certain things you don't do to it. There's certain things you do to it. There's certain things you look for to prevent happening. And you're actually doing asset management with your vehicles. So you take this logic and you take some of this common sense, and you literally, that's why we put this pyramid together, just to show that it's really not that hard.
In fact, one of our customers actually said this is their asset management business model. This is what they use now. And so, yes, we have things in addition to this pyramid. We've got a couple other things for road mapping, some other tools for helping figure out where you're at. But it doesn't have to be that hard, you know. And unfortunately, there are some folks out there that really like to make it complicated. It just ends up meaning they stay longer. We try to get you to be able to do it. Hopefully that answers some of the question.
Okay, and we've got a question about the criticality pilot. Does your quick pilot have a limit on the size? For that limited engagement, yes, we will work with you to define the scope, select a certain number of systems to do the analysis on. That's something that we can, you know, do on a case-by-case basis. We're not just doing a cookie-cutter approach. We would work with you. That first phase of discovery and engagement would be to help you identify where are we going to get the biggest impact for this pilot. So yes, we do have a limit on the size to keep it within the nature of a pilot, where you can quickly see the value. But at the same time, we will work with you to make sure that the pilot really does deliver value. Just a note on the pilot, you know, one of the things that is so important for any sort of asset management, asset performance management program is securing executive sponsorship and buy-in. And doing a quick pilot like this that can very clearly pinpoint and show the path towards achieving savings and mitigating risk can be very valuable in securing executive sponsorship for an expanded asset management program.
Yeah, and in fact, just to piggyback on that, one of the things that's included in there is actually an exercise to capture and memorialize and document actually what the overall, you know, objectives are, the mission, the categories. And this gives a lot of comfort actually to the executive management, knowing that whatever you're going to, you know, come discover is really been aligned with what they care about and what they're held accountable for and the stakeholders. And so it's also fully in line with the requirements or the intent behind ISO 55000, which is the International Asset Management Standard. We're not at this juncture suggesting that's something that you have to go for certification on, but you want to know that there's a comfort level that what you're going to do would be in support of at least those principles.
All right, last chance for any questions. I hope I didn't miss anybody raising their hand.
Would also say that on the pilot, you know, what's included too is a limited use of the software. So you get to you know, not only play with it, but see the simplification of the complexities that are possible. And by that I mean is, you know, when you can look at a lot of information, you can do this at a system level, you can do this at an asset level with failure modes and FAMICAs and all that. So the ability to multitask with the software and to deal with frequencies and probabilities, mess with it, you can do that, and that limited engagement does include some limited use of the software. So there's some significant value there.
All right, well, thank you so much, Tacoma.
Listen, real quick, the other thing I forgot to mention is the ability to actually engage with the existing CMMSs. So, you know, we've got a number of cases where we did the criticality booster on its own, and we're able to interface with and get those numbers into somebody else's CMMS. And so there's an immediate value there in that limited engagement.
Right, and that, you know, that can be SAP, Maximo, Oracle WAM, any of the large or small CMMSs that are in use out there.
Yeah, and I can't stress enough how important it is to have accurate criticality numbers and to have the numbers, the math behind it be used by the software accurately. You put in a bad criticality number and you're just going to make bad decisions.
So, well, that's a good point to wrap up, because good asset management is about enabling better decision making that balances risk, cost, and performance. As I mentioned at the beginning, this was going to be a bit of a top line whirlwind tour of criticality and risk. Lots more to be said, lots more to be understood, and point you again to our further resources. Just back up there, we've got the book, Criticality Analysis Made Simple. We have our YouTube video, and we have the opportunity to sign up for the pilot project. And thank you so much for attending today. A recording of this webinar will be made available, and we'll be posting our future webinar topics shortly. Visit our website, visit us on LinkedIn, and just let us know how we can help. Thanks for joining us.
Thank you very much, folks.